This video, we're going to go through a few exam questions on organic chemistry, but before we do that, let's review some main points. Now, remember the names for the organic molecules. They depend on the number of carbons. So if it's 1 carbon, it's meth, 2 carbon is eth, and so on. There are different types of organic molecules for your level at GCSE, IGCSE. You have to know the alkanes and then the alkenes. And for those doing triple award, also the alcohols, the carboxylic acids, and the esters, okay? Now, using butane as an example, there's different types of formula that can represent butane. The displayed formula shows all of the bonds. The structural formula is each carbon and the atoms that it's bonded to. The molecular formula is just the total carbons and the total hydrogens. The empirical formula is the simplest ratio of all the atoms. The general formula depends on what hydrocarbon you are. If you're an alkane, then you will have the general formula CnH2n plus 2. And if you're an alkene, then you're going to have the general formula CnH2n. Finally, the word isomer is important because they like to test that a lot. Now remember, an isomer is 2 molecules that have the same molecular formula but different displayed formula. So if we use butane as an example, the molecular formula of butane is C4H10. The displayed formula of butane is up here, right? Stretched out like that. So the isomer of butane will also have the same number of carbons and hydrogens. So it also has C4H10, but the displayed formula will be different. In other words, the carbons will be arranged in a different way. So instead of arranging 4 in a row, it might be C, C, C with a C like that. And of course, you have to fill in all the hydrogens. Does that make sense? Right? Okay, so that is an isomer. Don't get that mixed up with isotope, guys. Isotope is same number of protons, different number of neutrons. It's a completely different concept. Okay, great. So now let's do some actual past paper questions. Okay, so let's zoom in a little bit. All right, so this question here, we have a bunch of organic chem molecules. And it says the letter of the compound in the table that is not shown as a display formula is who? So remember what a display formula is. A displayed formula is all of the bonds needs to be shown, all of them. So therefore, who does not have all the bonds shown? It's got to be C, isn't it? Because look, it's not this carbon here. You're not seeing the bonds to the hydrogen. It just writes CH3, but if it's a proper displayed formula, they should be drawing carbon with the 3 hydrogens like that. Then that would be a display formula. So that's why C is not a display formula, right? Next, then it says, state what is meant by the term hydrocarbon and give the letter of one compound that is not a hydrocarbon. So the word hydrocarbon is frequently asked on the exam. So there's 2 points you want to mention for hydrocarbon. Number 1 is that it has, or the molecule has, carbon and hydrogen atoms. Now my students will know this is not enough to get full marks. The second mark is only. It's like writing a check. You know, you write the amount and then you write only at the end. So people can't add on more numbers after that and try to get more money out of your check. So only. That means if it does not only have carbon and hydrogen, then it is not a hydrocarbon. So who is not a hydrocarbon here? That's got to be A, because it's got a bromine. Everybody else is carbon and hydrogens only, isn't it? So that's nice and easy. That's hydrocarbon. And it says, state what is meant by the term unsaturated and give the letter of one compound that is unsaturated. Okay, so unsaturated, the word unsaturated means, it means that it has, the molecule has double bonds, It can just be one double bond, but as long as it has double bonds, then it is unsaturated. And who here has double bond? That would be B. B. Okay, nice and easy. So that is B. So that is unsaturated. And then lastly, it says, state what is meant by the term isomer and give the letters of 2 compounds that are isomers of each other. So isomers, always, you just write same and then different. That's how you revise, okay? So same what? Same what? Same molecular formula And what is different? The displayed formula, isn't it? The displayed formula, because there's the way the bonds are arranged that are different. So how do you figure this out? I advise you to write out the molecular formula for everyone, and then you can see who doesn't have this, who has the same molecular formula. Does that make sense? So let's do that. Molecular formula, I'll be putting it in green, right? So this one is a CH3Br. This one is a C2H4. This one is a, well, how many C's are there? We have 1, 2, 3, 4, 5. That's a C5. And hydrogens should be 12. 3 times 4 is 12. D, this is a C2H6. This one is a C3H8. And then finally, this is a C5H. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Isn't it? 12. All right. So can we tell who are isomers? Same molecular formula, C and F. They're both C5H12. And notice, guys, that it's arranged differently, isn't it? For this one, the C's are arranged sort of like in a cross, whereas here, the C's are arranged in a straight line. So therefore, is C and F. C and F. Done. Okay, next question. Next question. Okay. So the more we do this, the more you get used to organic chemistry. I still love organic chemistry when I was a student. All right, so this table shows a bunch of hydrocarbons, and these are all hydrocarbons. Remember, that is hydrogens and carbon atoms only. Give the letters that represent a hydrocarbon with the general formula CnH2n. CnH2n. So this is actually a general formula. Remember, for general formula, guys, there was 2 that we learned, isn't it? There's the alkanes, and then there's the alkene. And they have different general formula. Alkane would be a CnH2n plus 2. And then an alkene would be a CnH2n. So just by seeing this, I know that I'm looking for alkene. And I know that alkenes are unsaturated. We just talked about that. And what do unsaturated things have? They have double bonds. So these should all be linked up in your head. Alkene, CnH2n, unsaturated and double bonds. So who is it? Who has a double bond? Very obvious, right? It will be E. Okay. Then it says, state why B is the only hydrocarbon shown as a displayed formula. So remember, the word displayed formula means that it has to show all the bonds. Show all the bonds. And do you see how B shows every single bond? Whereas, I mean, look at this. They haven't shown any bonds. They should be really drawing as C, H, 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 like C4, H's like that. Do you guys understand? So everybody else except for B, they haven't shown you all the bonds. They haven't. They just got lazy and just wrote CH3, CH2. So that's why only B, you can see all the bonds. And by the way, so you guys have a bit more knowledge about looking at display formulas, carbon always has 4 bonds. Number of bonds. Carbon always has 4 bonds. Hydrogen always has 1 bond. Oxygen always has 2 bonds. And that's really all you have to know, because these are the main ones that are in organic molecules. And once you know that, you can really check, because look at this carbon. How many bonds does it have? 1, 2, 3, 4. So it's correct. This one carbon, how many? 1, 2, 3, 4. And this helps if you're ever drawing a display formula. You can check by making sure the number of bonds is correct. This hydrogen, how many bonds does it have? Just 1. See that? Okay, so it's a sort of like a check. Explain which 2 letters represent isomers. This should be much easier to you now. Again, you do all the molecular formula. Let's see if we can do this faster. This is a CH4. Nobody else has 1 carbon, so it cannot be A. This is 2 carbons. Does anyone else have 2 carbons? No, it doesn't. So it cannot be these 2, because I need to have the same number of carbons. This has 3 carbons, so this is more likely. So let's write this out. C3, H how many? This is C3H8. Anybody else has a C3? This one is a C3, but it's actually H6. So they're not isomers. This one is a C4H10. And F is a C4. And then 3 plus 2 is 5, plus 2 is 7. 3 plus 2 is 5, plus 2 is 7. Plus 3 is 10, so C4H10. Therefore, it's D and F, isn't it? These 2 are the isomers. Now, exam skill, when they say explain, especially if it's 3 marks, you're not just going to finish here, right? You're going to explain to me why. So what would you say? You would say exactly what we just revised. Isomers have the same what? Different what? Same molecular formula. Different what? What's different? different displayed formula. So just memorize that. And then you've got all 3 marks. And then finally it says, how many of the hydrocarbons are members of the homologous series of alkanes? So alkanes, what are our keywords for alkanes? Alkanes has got to have a general formula of CnH2n plus 2. I'm also looking for only single bonds, isn't it? Because saturated are alkanes, and that means only single bonds. So once I have this idea, I'm going to scroll up and see who fits this criteria. So let's zoom out and take a look. Who has only single bonds? So definitely not B and E, right? Because I can see the double bond right there. So not B, not E. Are the rest all alkanes? A, C, D, and F. They're all alkanes. So that's 4. There's 4 of them. A, D, C, and F. And you can check. A, D, C. And if you wrote out the, just to prove this to you guys, does it have a general form of CnH2n plus 2? Let's pick this one. So here, N is 4. So what is 2 times 4 plus 2? 2 times 4 is 8. 8 plus 2 is 10. There we go. C4H10. So therefore, they all have that same. You can always check that in the exam when you have time. Okay, next question. Okay, so more diagrams of organic compounds, and it says give the letter of the compound that is not a hydrocarbon. This is getting much more easier now, isn't it? Who's not a hydrocarbon? It's got to be S, because it's got to be R there, so not B but S. Yeah, because it doesn't have hydrogen and carbons only. Give the letters of the 2 compounds that have the same empirical formula. Ooh, empirical is the simplest ratio. How do you do that? Again, try to write out all the molecular, because once you have the molecular, then you can work out molecular by counting everything. So that's easy. So this is CH4, this is a C2H6, this is a C3H8, this is S is not even a hydrocarbon, this is a C2H4, and this is a C3H6. So that is molecular. Once you have molecular, guys, then you can work out empirical by making it the simplest ratio. So this is already simplest ratio, so therefore empirical is the same. This, can it be simplified? Yes, it can. Divide everything by 2, so it becomes CH3. This one, can it be simplified? No, it cannot, because it cannot divide 3 further into a smaller number. So that is also C3H8. So sometimes the empirical and the molecular is the same. What about T? I can definitely simplify that, and I can definitely simplify that. Okay, all right. So once I've done that, I should be able to answer here. It says, give the letters of the 2 compounds that have the same empirical formula. Once you've written it out, you see how easy it is? It's clearly T and U. So always do this on the test, then you won't get anything wrong. You won't miss anything. And lastly, it says, give the letter of the compound that is used to manufacture polypropene. Polypropene, poly means many. Propene, let's see if you guys can decode this for me here. Propene, how many carbons is that? Remember, 1C is meth, 2C is what? Is eth, 3C is what? Is pro. So the fact that it's pro tells me that is 3 C's. 3 C's. And then the fact that it, okay, so let's color code this. The fact that it's pro means that it's 3 carbons. And the fact that it says ene means that it is an alkene. And therefore, CnH2n. So therefore, the formula has got to be C3, because 3 carbons, and then 2 times the N, because N is 3, right? So therefore, I'm looking for someone that is C3H6. Who is that on this diagram? C3H6, that is U. So therefore, U is the answer. U is the answer. So continuing on, it says describe a test that can be used to distinguish between Q and T. So I've pasted Q and T down here for you guys. Q is here, and then T is here. So what do you first notice about Q and T? What's different about them? They both have 2 carbons, right? So they're both ETH. In fact, let's name them as a good exercise. So clearly Q is ethane and T is ethene. Agree with me because of the double bond. Now, how can you distinguish between an alkane and an alkene? You should know that there's a test for alkenes, is that because they have the double bond, it can open up to add something onto it. So the thing that they're adding onto is bromine. So you're going to add bromine water And the thing you have to know about bromine water is that it is brown color. So bromine, when you add that to ethane, it's not going to do anything to it because it's already saturated. They already have all these hydrogens bound to the carbon, and it's not going to do very much with the bromine. So since bromine water is brown originally, when you add it to Q, nothing really happens. So therefore, it stays brown. The solution stays brown. It's a solution because it's dissolved in water. What about T? You've got to understand what's going on here. So what happens for T, if I just loop this down here, is that you have your carbon like this. You've got to understand what happens. And then you're going to add bromine, which is brownish color, right? So that's brownish. So you're going to add the Br2. So what actually happens is that this double bond opens up. So when it opens up, therefore now it's a single bond, it's going to add the 2 bromines onto it. You see that? It's going to add the 2 bromines onto it. And these 4 hydrogens, they're still there. So don't forget them. So they're like that now. Do you guys see that? Are you guys convinced that when you have a double bond and you add a bromine to it, it's going to open up to grab onto each of the bromines? And since this bromine is no longer bromine because it's attached onto the C's now, there's no more brown bromine color. And the color turns colorless. So I'm going to repeat this. Very important point here is that anything with a double bond can be tested. You can prove that this thing that you've got has double bond by adding bromine water and then seeing it turn from brown to colorless. That is the test for alkenes, is a test for unsaturated compounds. So if you're ever asked that, you write, boom, bromine water turns brown to colorless. Done. Next, compounds P, Q, R are members of the same homologous series. So what is this one talking about? P, Q, and R. So it's this one, P, Q, and R. Okay, so these 3 basically. And give 2 characteristics of a homologous series. So what do you notice about P, Q, R? What series are they from? What group are they from? They're all single bonds. So therefore, saturated. Therefore, these are the alkanes, aren't they? These are alkanes, I hope you've realized. And this question gets asked a lot. Homologous series, 2 characteristics, just memorize this, okay? They share similar chemical properties, means that they react in similar ways because they all have single bonds. Similar chemical properties. The second point is they have the same general formula. What is the general formula for alkanes? CnH2n plus 2, right? Same general formula. And you can also say they have the same functional group. There's other things, but these two are the safest things to put down. So just remember these 2. So they're part of the same group. So in this case, the homologous series is the alkanes. Moving on, this is a displayed formula of an alkene here, and give the name. So name, always think 2 things when you're trying to name things. Number 1 is number of carbons. Number of carbons. How many is there? 4 carbons. That would be but. So that's the first part of my name. The second point you think about when naming things is what homologous series. Is it an alkane or an alkene? Well, I'm seeing double bonds, therefore it's unsaturated. This is an alkene. So therefore it would be a butene. And that is the answer. Butene. Okay, butene. Finally, draw the display formula of another alkene that is an isomer of this thing. Isomer, remember, it's also got to have the same molecular formula. So it's got to have C4H8 if you count the hydrogens. So I need to draw something else that also has 4 carbons. So let me draw my 4 carbons first. 1, 2, 3, 4. However, it's got to look different in terms of displaying it. So you look, for this butene, it's got the double bond between the first and the second carbon. So where can I put the double bond that will be in a different location? Can I put it here? The answer is no, because this is actually the same as this, right? Because it's just at the end. The double bond's at the end, so it's not actually very different at all. So I cannot put it there because it's not actually an isomer. Where can I put it that would be very different to the one already drawn here? I can put it between the middle 2 carbons. That would be completely different to putting it at the end of the carbons. Does that make sense? Okay. After you do that, you draw everything else because the other bonds are single. And then you fill in the hydrogens. Now remember the rule, carbon, 4 bonds, hydrogen, 1 bond. So for every carbon, you check, am I getting 4 bonds? Let's do carbon 1 first. How many more bonds does it need? It's already got 1 bond here. So I need 3 more. So therefore, I need to draw 3 more hydrogens. So you do this for every single one. Then you check the second carbon, this one. How many bonds does it already have? 1, 2, 3. So how many more does it need? Just one hydrogen. Next one, this carbon, it's already got 1, 2, 3, 3 bonds. So therefore, I just need 1 more. And last one, can you tell me how many more bonds I need to add to this one? How many does it already have? It's already got 1, right? So therefore, I need to add 3 more. And when you're done, guys, don't just move on. Check, 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 check. Does it have the same molecular formula? Does it have 4 carbons? 1, 2, 3, 4. Yes, it does. Does it have 8 hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. So you know that you have drawn the correct isomer. Okay, so lots of questions on isomers here. So here's another question on isomers. We're getting really friendly with isomers now, aren't we? And it asks you, what is the name of this isomer? So again, asking name. Number 1, how many carbons? 5 carbons. 1, 2, 3, 4, 5. 5 carbon would be a pent. Number 2, is it an alkane or an alkene? Well, I'm only seeing single bonds, so that's therefore it's saturated. It will be an alkane, so it will be a pentane. Pentane. And it says, draw the display formula of the other 2 isomers. In other words, I have to draw 2 more isomers of pentane. They all need to have C5H10. Because they have the same molecular formula. So everybody here has got to be 5 carbons and 10 hydrogens. So do this systematically, guys. Don't make wild guesses because you don't have time and you make mistakes and so on. So this is how you do it. For alkanes, it's all about how these carbons are arranged. So in this one, the carbons are arranged in a straight line. So I cannot draw another carbon that's arranged in a straight line. I cannot. So how can I draw it? How can I draw these carbons? I can draw... Let me test you. Can I draw it like this? Ignore the hydrogens. Just look at how the carbons are arranged. Well, this one, the carbons are arranged sort of in an L shape. Is that the same as the one at the top? Because it cannot be, right? The display formula needs to be different. Is this the same or different to the one at the top? The answer is the same. Because I just need to like sort of bend this up and therefore I get a straight line again. So that's the same as this one. So this one is wrong. Okay, I just want to remind you again, this one is wrong. So I'm going to put this here just to make the note that you cannot draw that. This is not an isomer. It's actually the same as this one. So how else can I arrange the carbons? I cannot put them all in a straight line. So I'm just going to draw 4. And for the 5th one, I'm going to draw it attached to this. Wow, look at this now. Is this the same as the one above? As the one on the original paper? Definitely not. This is a straight line. This is a T. Woo! So that is correct. And then I'll do the other one. How else can I arrange these carbons? How else can I arrange them? I'm going to draw 3 now. And I'll put one up here and one down here. And do you see how now they're also arranged very differently, isn't it? They're arranged in a cross shape. See? So these are definitely different displayed formulas. And after you've done that, please do not forget to draw in the actual hydrogens. Same rule, 4 bonds per carbon. Okay, so carbon, this one, how many more do I need? 3 more. This one needs 2 more. This one needs 1, and so on. Okay, so these are a bunch of hydrogens, drawing hydrogens, the most time-consuming part of organic chem. So let's try to make this as neat as we can, like that. And after you guys have finished it, what are you going to do? You're going to check that they all have the correct number of carbons and hydrogens. They should all have 10 hydrogens and 5 carbons. And if this is wrong, let me know. But it is correct. Now, this is a brilliant question. 5 marks, so you know you have to be very systematic. So it says here, ethane and ethene both react with bromine. Describe the differences in the reactions and then talk about the conditions, products, and types of reaction involved. So let's do this systematically. So ethane first. I'm going to draw this out so you guys know exactly what is going on. Ethane is C2H6. It's a alkane, therefore only single bonds, saturated like that. Okay? And it's going to react with bromine. If you guys still remember, bromine is brown. Okay, so I'm just going to use brown here. Okay, so plus bromine. And I'm going to draw, you guys know that bromine is Br2, isn't it? Because, it's in group 7, so it needs to share 1 electron. So it's a Br2 like this. I'm going to do it like that. Right, okay? So what happens next is, this is an alkane. You guys need to know that alkanes do substitution reactions. It means that one of these hydrogens is going to substitute with the Br. So that's what's going to happen. They're going to switch over. So what you get, the product, is you're still going to get your C's and C's, but the last pink H is substituted with the other brown Br. So you're going to get a brown Br here, and then in the other thing is, think about what's left, is this pink one is now substituted out, and there's one Br left, guys. Please don't forget that. So the other product is the HBr. Your equation has to balance, understand? So whatever you have on the left is got to equal to whatever you have on the right. You've got 2 C's, 6 H's, and 2 Brs on the left. You make sure it's also the case on the right. So that is the reaction. What type of reaction is this? So I've talked about the products, done. What type is this? This is called a substitution reaction. You have to know that. This is substitution. And what condition is required for this? Condition is I need UV light. That's just the way it is. Okay? Now, the other one is ethene. Ethene, I'm going to draw with black here, I guess. So ethene has a double bond, and it's got the 2 H's on each of the carbons, so C2H4. And now, you guys know this thing because we just covered it. It also has the 2 Brs, but what happens now is that when it reacts, it's going to add on to the double bonds, because the double bonds will open up. So therefore, I'm going to open up the double bonds, is now a single bond. The 4 H's are still there because they're not going anywhere. And now the double bonds open up to grab onto 1 bromine each, like that. So now that is the product. What type of reaction is this? I've talked about the product. What type of reaction? This is called addition. Addition. And you can even talk about the color change, right? It goes from brown to colorless in this case. Okay, so that's how you get these 5 marks. Tick everything off, guys. Make sure you've given the condition, done. The products, draw it out. And then the type, substitution, and addition. Okay, guys, last question to power through. It says, give a reason why compound X is not a hydrocarbon. I think this is very easy because it does not contain just carbons and hydrogen only. It contains an oxygen, so that's done. B, give the letter of the compound that is a saturated hydrocarbon with empirical formula CH2. So saturated, again, I'm looking for single bonds only, but it's got to have empirical formula CH2. So if you work out the empirical formula, so if you write it all out, you'll find that is this one. It's basically this one. So I'll prove it to you guys. The empirical formula is, well, first of all, the molecular formula is C4H, 1, 2, 3, 4, 5, 6, 8. And then the empirical formula is the simplest ratio, so to divide everything by 4, and therefore I'm going to get CH2. So it is a CH2 empirical formula, but it's also saturated, meaning that I'm only seeing single bonds. You see that? So therefore the answer for this one is W. But the next question is what I really want to talk to you guys about, which is a very good question. Now, let's see. It says, give the letter of the compound that produces 9 moles of water when 1 mole undergoes complete combustion. When I first read this, I knew that some of my students might not be able to figure this out. So this is a very good question to practice, and I actually think it's worth more than 1 mark. Now, do it step by step. Ask yourself, what do I know about this question first? Complete combustion, you know what that is, right? That is when a hydrocarbon, so let's call that X. Let's not call it X, actually, because there's just X over here, okay? So let's just say a hydrocarbon. Hydrocarbons are C something, H something. What's combustion? Is burning in oxygen. Burning in oxygen. And then what's the product of complete combustion? Complete combustion is CO2 plus H2O. Okay? So follow so far. So that's the equation for complete combustion right there. And then it says 9 moles of water. So I'm going to put a big fat 9 over there. 9 moles of water. Now the magic happens. Look at the products. The 9 moles of water gives you how many hydrogens? Gives you 18 hydrogens, right? 9 times 2 is 18. And those 18 hydrogens must come completely from the H in the hydrocarbon, isn't it? Because there's no other H's in the reactants. All of the H came from the C something, H something. Therefore, I would conclude that since there's 18 hydrogens there, it's got to be 18 hydrogens here. Do you get it? Are you convinced about that, isn't it? So it's got to be 18 hydrogens. And once I figure that out, I know who it is because I'm just going to count who of these, the V, W, X, Y, Z, who has 18 hydrogens. And it's pretty obvious, it's V, isn't it? You can count it and you'll count 18. So therefore, the answer to this is V. That's how you do this question. And then lastly, it says, give the structural formula of Y. If you guys forgot what structural formula is, what color is it? It's in pink, right? So that is basically, you name every single carbon, 1, 2, 3, 4, and then you just write down what is attached to each carbon. So C1, what do I have on C1? I've got 2 hydrogens. So that's CH2. CH2. And then what do I have on C2? That's just 1 H. So CH. Someone tell me for C3. What do I write for C3? CH2 again. And then C4, CH3. So that is structural formula. Okay, so the best part of the video, which is a 1-page recap. Let's go. Pink box definitions, unsaturated, keywords, double bond, hydrocarbon, keywords, carbon and hydrogen atoms only. Displayed formula is when you see all the bonds. And speaking of display formula, the yellow box shows you a displayed formula of butene. When you name something, you think 2 things. Number 1, number of carbons, 4 carbons. Number 2 question is it an alkane or an alkene? Since I see the double bond is an alkene, therefore it's a butene. That's naming. And speaking of display formula, whenever you draw it, you check that all your carbons have 4 bonds, all your hydrogens have 1 bond. And if you're drawing oxygen, all of them have 2 bonds. Okay, red box is just a bunch of different types of formula, and I have that in a separate video. The isomers is a very important concept. Definition is same molecular, different displayed, and we have 2 examples of it. The blue one on the left hand side, these are isomers of C5H12. They all have C5H12, but the display form is very different. Similarly, the purple one, that is isomers of pentane, and if you ever have to draw them, just think of how to arrange the carbons. They've got to be arranged in completely different ways. Finally is the black box. These are types of reaction. The types of reaction you need to know for alkane and alkenes include substitution and addition. Also note the condition. Substitution requires UV light. And finally up here, please remember the test for alkenes. The test for double bond, what do you use? What do you see? You use bromine water and you see that it turns from brown to colorless if it is an alkene. Double bond, see right there? Whereas if it's an alkane, such as this one up here, it stays brown, no change.